Hello, this is the first video of a fourth calculus series on integration techniques for OCR Pure Core Further Mathematics, and we will look at integration using arc sin x. If we consider the integral 13 over the square root of 7 plus 4x minus 2x squared, we will note that this is in the form where the denominator is c plus bx minus ax squared. Now we already know how to integrate 1 over the square root of a squared minus x squared, and that the standard result is arc sine, or sine to the minus 1, of x over a plus c. So if we could transform the top integral into a form which allowed us to then use the standard integral, we would be able to solve it. In this example, we're asked to show that the integral can be rewritten as 13 over root 2 integral of 1 over square root of 9 over 2 minus x minus 1 squared, and hence find the integral by using this standard result here. Let's have a look at 7 plus 4x minus 2x squared and see if we can't get it to this a squared minus x squared form. Well, the first thing I'm going to do is divide by 2, but I'll be careful to put that factor in later. So if I look at 7 over 2 plus 2x minus x squared, I notice that I can complete the square, and that this will give me 7 over 2 minus x minus 1 all squared, and then I've got to be careful with signs here, but plus 1. This would give me then 9 over 2 minus x minus 1 squared. If I use this in this initial integral, that would then give me, still got my factor of 13. I'm not going to forget that factor of 2 that I divided by there, and then I'll have a bracket with 9 over 2 minus x minus 1 all squared, which rearranges to being 13 over root 2 outside the integral sign, and then 1 over the square root of 9 over 2 minus x minus 1 squared dx. I can see this is now of the right form. With a equal to 3 over root 2 and x being replaced by x minus 1 in the standard result. Now I could use a substitution here with u equal to x minus 1, but I note that du by dx will just be 1. So actually, I'm not going to bother with that substitution. I'll just use the standard result, being really careful about the factors. So I know I'm going to have my 13 over root 2. And then I'm going to have arc sine. My equivalent of x will be x minus 1. And a, if I remember, will be 3 over root 2, because this is my a squared term. So that would then be root 2 over 3 of x minus 1. And then I mustn't forget my plus c. If I did use the substitution, then you can see that it would just become minus u squared there and have the u there, and then I would just substitute back, but I would get the same answer. So in the summary then, here I have managed to deal with an integral of the form k over c plus bx minus ax squared. I've taken out factors to give a numerator of 1 and a coefficient of minus 1 for x squared. I then complete the square of the remaining expressions, being really careful to think about my signs and get those right. I can substitute for the squared variable expression, but if I find that du by dx equals 1, I may not bother, but just go straight into applying this standard integral here, being careful to identify the value of a. If I did use a substitution, I would then have to reverse that to get an expression in the original variable, usually x. I note that items 3 and 5 may be a bit omitted after practicing the technique, as long as I have this situation up here. In the next video, we will look at further integrating using arctan x.